All right, we're on to page number 5. I guess this should have been before the other one, but let's start with SOHCAHTOA. What does that mean? That means sine is equal to opposite over hypotenuse. The cosine of theta is equal to the adjacent over the hypotenuse, right? Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the tangent is equal to the opposite over adjacent. So this just helps you memorize that. It's interesting to see that tan is the only one without the hypotenuse in there. One always is missing one though. So when I get a question like this and I have to solve for a side or an angle, I have to think which one of these three am I going to use. So if I'm given this angle, I'm going to label the sides according to this angle. So I look across, so x is actually opposite, and I'm going to look beside, and that is adjacent. This one is the hypotenuse, but I'm not interested in it. But make sure you don't give this one either opposite or adjacent. It's special. It has to do with the 90 degree. Doesn't matter about the other angle. So I'm going to look up here and say which function uses adjacent and opposite. That is the tan of theta. So tan of theta equals opposite over adjacent. Now on our reference sheet, I gave you guys some triangles. I'll just write T. Tan equals opposite over adjacent. So if I know I'm solving for the opposite, I cover up the opposite, and I know the opposite is equal to the tan of theta times adjacent. That's what that means, times there. So that helps for rearranging if you want to do that. Don't forget tan of a number or tangent of a number. That's the angle is trapped in there. That's a number. That's why I put the brackets around it. The adjacent was 4 meters. You can leave out the units. Now I just do this all in one step on the calculator. So the tan or tangent of 70 is equal to 2.747, but I need to multiply that by 4, and then I hit equals 10.989. Let's round that to 1 decimal place, so that's actually x in this case. X is equal to 10. Whoa, this is a tricky one because this 8 pushes that up 1, and that's already a 9, so that's going to push up to 11, and that's going to be a 0. And that had a units of meters, so this must have a unit of meters. Okay, let's go ahead and do the next one. I'm given this angle. I go across, that is opposite, so this is the opposite. This is the 90 degree, so that is the hypotenuse. So I'm going to take a look up here, opposite and hypotenuse. Oh, that's opposite, it's sine of theta. So sine of theta equals opposite over hypotenuse. So I can make a special triangle for that one. And like I said, that's on your reference sheet. Sine equals opposite over hypotenuse. It's multiplication here. This line means division. So what am I solving for? I'm solving for the opposite. So I cover up the O. That means opposite is equal to the sine of theta. That's a number, times the hypotenuse. So I'm going to take a look and now sub in what I have been given. Opposite is x. Theta is 33. Whoops. And the hypotenuse is 24. So I'm going to do that on the calculator over here so you can see that. Clear it out. Sine of 33. The sine of 33, I can hit equals. See, that's a big decimal. And I'm going to multiply it by 24. And I hit equals, and I get 13.071. Give myself a couple extra digits. And I'm going to round that to 1 decimal place. So I'm going to look at these ones. That was what I'm going to keep. But the 7 is over a 5. So that's going to round up to 13.1. It's meters. We'll check that out and see what units that was. And there we are, 13.1 meters. Okay, I'm going to slide up so you guys can see the next triangles. I won't be able to see my functions in there now. Maybe I could sneak them in there. There we go. Alright, so here's my angle. And I'm going to go over and look. That one is opposite. I'm going to look beside. That one is adjacent. So opposite and adjacent, that's tan. So tan of theta equals opposite over adjacent. This time I'm solving for the angle. So that means when I'm solving for the angle, I need to use the inverse function of the tangent. And that one isn't, we're not rearranging the equation, we're just trying to get rid of this. The way we get rid of that is do the tan inverse, tan theta. Whatever I do on one side, I have to do on the other side. So can I sub in opposite is 20, adjacent is 5. I'm just going to show you that I'm taking the tan inverse on both sides. Doing the same thing on both sides. So that gets rid of that, and I'm just left with theta on that side. On this side, I'm left with the tan inverse, and I probably could simplify that because 20 divided by 5 is 4. So go ahead and get your calculator. Now for this one, you're going to need to do shift, or second function, because the inverse is in this orange, and you can see shift is orange. So shift, tan, the number 4, hit equals, I get 75.96. And that makes sense for an angle. Usually angles are rounded to the closest degree. So I'm going to look at this one, look at that first decimal, it's over 5. So theta is approximately equal to 76 degrees. Done. Hopefully you can see that. Alright, and on to our last triangle. Here's my angle. So I use that angle to label my sides.